I don't know. Things are looking up this week. I'm starting to feel better. My tile that I've been trying to get at my house for 7 weeks is supposed to come today. Please be here today. It's supposed to be today. I've been tracking it. It made it to Fort Smith on a truck last night. So, or like 3 a.m. this morning, actually. So hopefully today they're driving it up the mountain and going to drop it off at my house. So 3,000 pounds of tile, 2 pallets of tile, 100 boxes of tile. It's a lot of tile. We ordered a lot of tile because our room is huge. So it's like 700 square feet of tile. But we're kind of bougie. It's from Italy. We got Italian tile for our kitchen and dining room. Didn't know that when we picked it out, but since then I've learned, oh, it's made in Italy. That's why I'm having such a hard time getting it. Nobody has it in stock, at least not 700 square feet of it in stock. Let's see. All right, guys. Well, I don't see anyone else filtering in, so let's go ahead and get going with. Oh, I need to get my screen ready here. So we'll be ready to take a look at what's going on this week. Or Algebra 2. So how's matrices going for you guys? We just got started with them a little bit, but hopefully everyone's. I know the ones that I've had people turned in have been doing really well. I've seen lots of 4 out of 4s. 4 out of 4, 4 out of 4, and it's like fabulous, good job. Because you can retake it if you don't get 4. You miss one, you get 3 out of 4. Just go back to Buzz, click on the link again, go back and redo it. Get a 4 out of 4, or you turn it in. You don't have to turn in a 2 out of 4 or a 3 out of 4, unless you just, I don't care. I'll take 3 out of 4 this time because I've got a good grade. But it's easy points because you can redo it as many times as you want to, and then just turn in the one you want. So take advantage of that, guys. Take advantage of that. When you get a chance to get easy points, because you can redo it all you want to, then redo it and get full credit. Make it easy on yourself. So, all right, let me put this up, see what we got this week. More matrix stuff. We got a couple more weeks. We got like 3 more weeks of matrices. I like matrices. They're very, very handy, very useful. Let's see. I do need some paper today because we are going to do one. Let's see. I had a blank sheet of paper and I've got it mixed in all these other notes that I've got. Let me just grab a sheet. Okay, we'll get to that. We'll get to that. All right, let's see. Oh, look at my grade. I must not have turned in my matrices last week. I've been enjoying it so much. Well, last week it was busy. It was the last week of bowling. I'm done with bowling now. But yeah, I did not turn in. I will go back and do those matrices because I think they're kind of fun. So, but yeah, last week. Oh, yeah, I guess I should talk about that. I was like, why did I not do these in class? Because I've been doing class. Last week, you had an ed puzzle to watch. So hopefully that went well for you. Still, the matrix assignments are right there on Khan Academy, so they're easy to do. But yeah, I didn't get to be here in person with you last Tuesday, and I hate that. But I was out all day at a bowling tournament, and that was the end of our season. So I'm feeling a little relieved not having all that extra time demand on my schedule. But yeah, I wasn't here in person. So, if you were confused about something, please let me know. I'll get it straightened out. But hopefully this week, as we go through it live together, that'll help if you were confused any by last week's video. But hopefully it was clear and understandable to where you knew how to get these things done and how to turn them in. But we will do some together this week to make sure we got it. And I'm going to go back. I'll go back and get mine done from last week that I didn't get done. So this week, basically all we're doing is we're going through the folder. We're doing week 24. You see, that's what February 16th is, week 24. So let's go back to the activity screen. And I've closed the module 5 folder. I had it open. Close the module 5 folder. And going through matrices, make sure that you have joined my class in Khan Academy, 5th hour right there. Make sure when you go to Khan Academy that you're logged in, because if you forget to screenshot it or something, it'll keep track of it for you. So when you go back, it'll show that you scored 4 out of 4 or whatever. And that's great. You don't have to redo the whole thing. But basically, the way we go through this is you just do everything in the folder. Go through the entire folder. Like last week was week 23, and week 23 had 2 folders in it. And when you open the first folder, you had 2 lessons, 2 assignments, and then the second folder had 1 lesson, 1 assignment. So that was last week. So we're done with week 23. Looking at week 24, let's open that up. It has 2 folders and a quiz. If we open the first folder, we've got 1 lesson, 1 assignment, and the second folder just has a lesson. So we just have 2 things to do this week. We have an assignment, and then we need to go through this lesson here before the quiz because we need to know what's on there because it's going to be quizzed as well. And the quiz is over both weeks. It'll have stuff from last week and this week. So we're going to start with the first folder, elementary matrix row operations. So got to pay attention. You can get a little bit confused if you're not paying attention here, but we'll go through these matrix row operations. So when you click on there, it's going to have the link that'll take you to where the lesson is. So let's click on that and let it open up this other window for us. Loads pretty slow for me. I don't know how it does for you guys, but I've got it really big right now. So we'll see if that's too big. But now I always close this little half page. There's this little arrow in the middle. You can close that. I don't need that taking up all my space. So that way I've just got the main part right here. I want to make this a little smaller right now. I want you to be able to see plenty of the screen. 110%. All right. So we're going to talk about matrix row operations, things we can do with matrices. So there are 3 elementary operations that we're going to use with matrices. And here's what we can do. We can switch any 2 rows. So for example, if we have this matrix that's 2, 5, 3, and 3, 4, 6, we could just trade places. We can put the 3, 4, 6 as the first row and the 2, 5, 3 as the second row. Just interchange the rows. That's no big deal. It doesn't create any problems. It's just like if we had 2 equations, it doesn't matter which equation we list first. If we're solving those systems of equations, it doesn't matter which one's first. We can multiply a row by a non-zero constant. Like right here, we took 2, 5, 3 and multiplied but times 2, just the first row. So it becomes 6, 15, and 9. And the second row stayed the same. That's okay. 3, 4, 6. It didn't change the second row. But we multiplied row 1, and it's now 3 times larger than it was. Or we could do something like this. Row 2 becomes the sum of rows 2 and row 1. So row 1 didn't change. 2, 5, 3 is still 2, 5, 3. But we took the second row and we added the first row to it. So we added the 2 x's, like if this was linear systems, 2 plus 3, so that becomes a 5. 5 plus 4, that becomes a 9. And 3 plus 6, that also becomes a 9. So we're going to use these 3 operations to manipulate our matrices. We're going to manipulate our matrices with these 3 operations. So, and remember, you can go back to this lesson anytime and click on it and go through this again and to make sure you understand it. But let's talk about the first operation, switch any 2 rows. And this is how you'll see it written. Row 1, a double arrow at both ends of the line, row 2. So that means take row 1 and row 2 and swap them. So if we have this matrix 4, 8, 3, 2, 4, 5, 7, 1, 2, and we have this right here, R1, R2, this matrix would become this, 2, 4, 5, 4, 8, 3, 7, 1, 2. Notice 2, 4, 5 was the second row, but we've taken and moved it up to the first row. And we've taken the first row, which was 4, 8, 3, and made it the second row. And the third row, nothing changed. The third row stayed exactly what the third row was because it did not say to do anything with the third row. It said swap the first row and the second row, but no mention of the third row, so the third row just stays the same. You may see that written like this, where they'll put it in between the matrices. See, it shows the first matrix, and then you'll see the operation there, R1, double arrow, R2, and the arrow saying it started as this, and now it's this, where we have replaced row 1 with what used to be row 2, and we've replaced row 2 with what used to be row 1. and the third row is not changed. So now that they've showed us that, we get a practice problem where we need to try this ourselves. All right, so I'm going to open up the chat so I can see what's going on in the chat. And I want you to tell me, and I'll make this bigger just so see it as well as you can on your screen. That's pretty big. If we perform this row operation right here, it says R2, arrow, arrow, R3. Tell me what the first row of numbers needs to be for this matrix. The first row of numbers. In our new matrix, after performing this operation, what numbers are on the first row? Look carefully at what the operation says to do, because it can fool you if you're not paying attention. Got two different answers right now. Waiting on more people to log in. Oh, here comes some more. All right. Yep. Very good. It did not say to do anything with the first row. It said row 2 and row 3. So the first row just stays the same. Nothing happened with the first row. It's still 729 because it did not say to do anything. So what is the second row now? Perform the row operation R2, R3. So the second row. All right, Bridget's chimed in. All right. Yeah, the second row becomes the 1, 3, 12 because it said to take the third row and make it the second row. So that means the new third row, 6, 4, 1, right? Because we were supposed to take row 3 and row 2 and trade places. Swap those. By the way, when you're and I don't remember if I emphasized this in the video last week, when you're in Khan Academy, make sure it shows your name up in the corner. See, mine says Mr. Brock up there. That means you are logged in. Make sure you're logged. Just use your school Google login and make sure you're logged in. So, all right, let's check and see if we're correct. Hit the little check button. Yes, we got the little green check mark. We did it correctly. All right, here's another question. Perform this row operation. So what will be our first row? What's the top row of numbers? What are we putting right here? Performing this row operation. All right, seeing some good answers pop up there. Yeah, if we look at what the command says, our command says to take row 3 and trade places with row 1. So our new row 1 is the old row 3. Remember, you can go through and this will give you entirely different problems. So if you want to practice this, click on this lesson, go down and practice for yourself to make sure you understand. If you're not 100% confident, go practice this before you do the practice assignments that count. All right, row 2. Are we doing anything with row 2? This does not mention row 2. It mentions row 3 and row 1, which means row 2 stays the same. Absolutely stays the same. Good job, Heidi. And then row 3, what are we doing with row 3? We got a challenge problem coming at the end of this. I can't wait to that. See how you guys do. I thought I'd trick some people yesterday, but most people were right on top of it. They got the challenge problem. Yeah, row 3 is the old row 1. Good job, Eiley. 2, 11, -5. Yeah, let's check that. And we get the green check mark. Fabulous. Let's go on and look at our next operation. So this says multiply a row by a non-zero constant. So you'll see a command that looks like this: 3R2 and then an arrow R2. So this means take row 2 and multiply that row times 3 and replace row 2 with that new number. So, for example, let's scroll down. Here's the matrix, 661, 230, 459. So that means we're going to take this 230, because that is the second row, and we're going to multiply all the elements in that row by the number 3. So it becomes 3 times 2, 3 times 3, and 3 times 0. So now our matrix will look like this. 661, because nothing happened to the first row. It stays the same. The second row is now 690. It was 230, but when we multiply all of those numbers times 3, it's now 690. And then the third row, 459, is still 459 because it did not say to do anything with the third row. It only said take the second row, multiply it times 3, and replace the second row with the new numbers. And again, you may see it like this, where they'll just put the operation in between the old and the new matrix. Here's the old matrix. After this operation happens, here's the new matrix that's created. 690 replaces the second row. Notice there are 3 here. 3 times the second row replaces the second row, but the other rows remain the same. All right, so here's our practice problem. We're supposed to perform this operation on this matrix. So seeing this matrix and performing this operation, what is our first row going to be in the new matrix? Give me some time to think about that one. All right, Heidi's got an answer. So it's Eiley, Kaylin, yep, answer report in. Good job. All right, let's put that in. See how you got. You're nailing it. Yeah, take 2 times the first row and replace the first row. So if this number was 2, when we multiply it by 2, it's 4. The second number was 6, so that becomes 12. The third number was 5, that becomes 10. And the last number was a 1, and that becomes 2. What about the second row? What do you think? 14, 8, 16, 0? See if I can throw anybody off the trail there. No, I know I'm not going to get you with that. Nothing happened to the second row. It stays exactly the same. Yes, that's correct. You guys, I couldn't trick you. So check this. Perfect. Oh, they give us a second one. Oh, okay. What's our first row for this matrix? Look at our operation up there. Look at our operation and tell me what the first row is going to be. Bridget's got an answer there, which is very close, but I don't know. Is Bridget right? Oh, Madison's got a little bit different answer. Yeah, Bridget, you missed that negative. Remember, there's a negative too. Couldn't see the negative. I understand. Yeah, if you don't have a real good high-speed connection at times, it gets a little fuzzy. I've noticed that. Depending on how your internet connection is doing at your house and how my connection is doing here, sometimes it's clearer than others. But yeah, there is a negative too. Okay, the second row is a 7 and a 4. So what's our second row going to be in the new matrix? I'll try and say the numbers for anyone that's having trouble seeing if there's a negative. There's no negatives in the second row. Yeah, and it stays 7, 4. Okay, our operation has a negative in it. It has -5. There's a -5 in our operation. The third row is a -3 and a 6. So what numbers will be that now? Oh, I see a lot of folks popping in there. So we have a -5 times row 3. is replacing row 3. So -5 times row 3. -5 times -3 is a positive 15. You guys are on top of this. And a -5 times a positive 6 is a negative 30. Check. Hey, we got the green check. All right. Okay, here it gets a little trickier. Add one row to another. Example, perform this row operation. Row 1 plus row 2 becomes row 2. So if we have this matrix, 2, 3, 4, 0, 8, 1, and we do row 1 plus row 2 replaces row 2, that means replace the second row with the sum of the first and second rows. So 2, 3, 4, 0, 8, 1 becomes, and notice, even though we're adding these together, we still have the same first row because we did not say to change the first row. We said to change the second row. So the first row is still 2, 3, 4. But look at our second row now. It was 0, 8, 1, but we add the first column, 2 plus 0, and it becomes a 2. And we add 3 plus 8, and it becomes an 11. And we add 4 plus 1, and it becomes 5. So our new matrix, which they may show it this way, 2, 3, 4, 0, 8, 1 becomes 2, 3, 4, 2, 11, 5. Notice how the sum of row 1 and row 2 replaces row 2, but the other row stays the same. All right, so don't let that fool you as we try our practice problem with this operation. All right, so let me just look. All right, perform the row operation, row 1 plus row 3, arrow row 3 on the following matrix. So what is our first row then? There's a -1, 6, -2 is our current row 1. -1, 6, -2. So yeah, it just stays the same. Right. Yep, you guys are on that. The second row is -3, 5, 0. Yeah, and it didn't even mention negative, that the second row, so the -3 and the 5 and the 0, they just stay. The third row was 7, 2, and 1. What is our third row going to be in the new matrix? Because we had a -1, 6, -2, -3, 5, 0, 7, 2, 1. Yep, gotta take your time and be careful with this. Be careful with the operation. Oh, you guys are killing it. Yeah. So it says to take the first row and the third row and add them together and replace the third row with that number. So -1 plus 7 is a positive 6. 6 plus 2 is a positive 8. -2 plus 1 is just -1. Check. No problem. You guys are nailing this. Now what are we doing? Row 2 plus row 3 is row 2. So it didn't mention row 1. I'll go ahead and put row 1 in. I know I'm not going to fool you guys with that. What's our new row 2? There's no negatives on row 2 or 3 if you're having trouble seeing it. 8, 9, 12. 8, 9, 12. I see a lot of people with that. All right. When we add 7 plus 1, we get 8. When we add 4 plus 5, we get 9. 2 plus 10 is 12. And of course, then that leaves our third row, which we added to our second row. So does that change our third row? No, our third row stays 1, 5, 10. Doesn't change the third row, right? It said to add it to the second row and replace the second row, but it didn't say to do anything different to the third row. So let's do our check. And we got our little check mark. All right. Challenge problem. I've been waiting on this one. Okay. So tell me what the first row is going to be after we perform this operation. Row 1 plus 2 row 3 becomes row 1. All right, I'm going to go ahead and put row 2 and 3 in there because I know I can't fool you guys with that anyway. they stay the same, but it did say to replace row 1. So I'll give you a moment to look at that and figure out what the new row 1 is going to be. Delilah's quick on it. She believes she's got it. And she just might. Oh, Braden got a little bit different answers. Let's see where we got with that. Make sure you're looking at the right rows there. We've got different answers, so I think we're looking at different rows. You can't read the operation. It says row 1 plus 2 row 3 becomes row 1. Braden figured it out. He did the second row instead of the first row. So row 1 plus twice row 3. So if we take row 3 and double it, comes 16, 16, negative 12. 16 plus the first row, negative 5, comes 11. 16 plus 7 becomes 23. And negative 12 plus 3, negative 9. Check. All right, you guys nailed it. Let's see. Now we want to look at why would we do all these operations up here? It's because we can use this to solve a systems of equations. So we're gonna work this out. I'm going to show you this. So if we have this system of equations, and this is what we looked at last week, how can we take a systems of equations and turn it into a matrix? Remember, if we have 1x plus 3y equals 5, 2x plus 5y equals 6, we just make an x row with just the coefficients, 1 and 2. That's the coefficients of the x. The y column is 3 and 5. And then there's like this little dash line that means that's really an equal sign in our original equations. So we put the 5 and 6 on the right side to show that's where the equal sign would be. So we have an x column, a y column, and then our equals 5 and equals 6. So this is called an augmented matrix because of that little line. So we can perform all these row operations on this augmented matrix. So we can switch 2 rows. If we take the 1, 3, 5, 2, 5, 6 and swap them to 2, 5, 6, 1, 3, 1, that's just like rearranging the order that we wrote the equations. That doesn't change anything. That's still fine. It's still legal mathematically to write the equations in the other order. So switching rows doesn't change anything. It's fine. It's legal. We can interchange any 2 rows. How about multiplying a row by a non-zero constant? So if we have, these are equivalent systems. If we decide, and remember, if you think back to when we were doing this back at the beginning of the year, solving systems of equation. If we had these 2 equations and we wanted to solve it, one way we did it was by elimination. So we said, well, if we multiply the first row by negative 2, then we would have negative 2x and a positive 2x. And when we add these together, the x's go away. Remember, it eliminated the x. That was one of our solution methods to get rid of the x, is by multiplying the row by a number that would cancel one of the variables out. So when we had x and 2x, we'd multiply that. Well, that's the same thing with our matrix. When we multiply a row by negative 2, it just changes the matrix times negative 2. We were doing those up above on the screen, just multiplying by a non-zero constant. And the reason you do that was the same reason that we did that in systems of equations, is because we were trying to eliminate a variable somehow. So that's a legal operation. It's still, x is still going to equal the same thing. Y is still going to equal the same thing because we've doubled all the values, and we've done it on both sides of the equal sign. So that means the equation is still equivalent. So that works fine. Adding one row to another. Well, see, we did that after we made negative 2x and positive 2x, we added the rows together so that we could get rid of the x. And that meant negative 6y plus 5y was negative y equals negative 4. That got us to that point. So we knew y equaled 4 at that point. So we could do that in our matrix. If we add these rows together, and make that the new second row. See, the second row is replaced by adding the first and second rows together. -2 plus 2 is 0. -6 plus 5 is -1. -10 plus 6 is -4. And that gives us the same thing here, that -y equals -4, right? Because there's no x anymore. -y equals -4. So we can solve equations that way. So concluding the challenge problem here, arrange the row operations according to each step. All right, so I'm going to have to make this smaller because there's a lot of steps on the screen. I said if we were solving, gosh, I have to go even smaller, don't I? If we were solving this systems of equation right here, here's the original matrix. We've got 2, 2, 10, -2, -3, 3. What did they do in step 1? How did they get from this to this? And here's the 4 operations, and we can rearrange these in whatever order we want to. See, we can rearrange them. So we're trying to figure out what did they do right here to go from this matrix to this matrix. And they may have, see what changed. Row 1 did not change. Row 2 became 0, -1, and 13. So did they subtract row 2 from row 1 and replace row 1? No, because row 1 stayed the same. So it's not this one. It's one of these other ones. And it's not this one because that one also replaces row 1. So it's either they added them or they multiplied it times -1. Well, it was -2, -3, 3, and it became 0, -1. So they didn't multiply it by -1. That's not right. Or it still have the same numbers, just the opposite way. So they must have added the 2 together. Row 1 plus row 2 became the new row 2. All right, so they added row 1 and row 2 because 2 plus -2 is 0. 2 plus -3 is -1. 10 plus 3 is 13. So that's what happened. Now we went from 2, 2, 10, 0, -1, 13 to 1, 1, 5, 0, -1, 13. So nothing happened on the second row, but the first row changed. So did they take -1 times the second row and replace the second row? No. Did they subtract row 2 from row 1 and make it to row 2? I'll make it row 1. Well, let's see. If we had 2 minus 0, it wouldn't be 1. So it looks like what they did is they multiplied row 1 by 1/2. They cut it in half. It used to be 2, 2, 10. Now it's 1, 1, 5. So that's the operation that happened. Then we went from 0, -1, 13 to 0, 1, -13. So this one is correct. They did multiply it by -1. So the last one, they just subtracted it. Now I want to go through this on paper to see what is going on. So I'm going to first write down the matrix that they used at the top. All right, that's the matrix they started out with. They had 2, 2, 10, 2, -2, -3, 3. So they're solving this systems of equation. This is 2x plus 2y equals 10. And this is -2x -3y equals 3. Okay. Now, if we were solving this systems of equation, we would add these together to get rid of the x, right? Because 2 plus a -2, there's no x's. And this would be a -y, and this would be a 13. Well, what they did with the matrix, they said, okay, we're going to leave the first row alone for now. And the second row is going to become row 1 plus row 2 will become the new row 2, which is exactly what we did over here. We added row 1 and row 2 together. Add row 1 and row 2 together. 2 plus -2 is 0. 2 plus negative 3 is negative 1. 10 plus 3 is 13. Well, look, we've got no x's, negative 1y equals 13. We have this right here. That's what this is on that second row. All right? So then it's like, generally we would multiply this by negative 1, right? Multiply both sides by negative 1, and this becomes y equals negative 13. Well, they did that 2 steps later. They did this first, but let's do that right now. Negative 1 times row 2 becomes row 2. We can do that at any point in the order while solving this. So the first row stays the same. The second row becomes positive 1 and negative 13. So now we've got y equals negative 13. Working our way through this. We still need to get this to where it's x equal. That's what they're trying to do. If we can get this to x equal, we can solve for x. Well, that means this row needs to be a 1. What we need it to look like is an x with 0 y's, and it equals something, right? That would give us x equals. We've got y equals 0, 1, negative 13. So our goal is to just have an x on this row and just have a y on this row. And that's how we're solving this systems of equations. So we can get this to a 1 by multiplying 1/2 times row 1, making that the new row 1. So the top row becomes 1, 1, 5, and the bottom row is still the same. All right. Now, what if we subtract the second row from the first row and make that the new first row? So R1 minus R2 becomes the new first row. I'm not changing the second row. It's still 0, 1, negative 13. But 1 minus 0, 1. 1 minus 1 is 0. 5 minus negative 13 is at positive 18. So now I've got x equals 18 and y equals negative 13. And that's the solution. And you're like, really? Well, let's see. If this is the equations, this should work in both equations. 2 times 18, 2x, 2 times 18, plus 2 times negative 13 is y, should equal 10. Well, let's see. 36. 2 times a negative means minus 26. Hey, that checks out. 36 minus 26 does equal 10. Let's try the second equation. Negative 2 times x minus 3 times y equals 3. See, negative 2x minus 3y equals 3. Negative 2x minus 3y equals 3. Negative 2 times 18 is negative 36. Negative 3 times negative 13 is plus 39. And that does equal 3. Negative 36 plus 39. So this is the actual solution to that system's equation. But we can find it by doing these matrix operations. That's how matrices are used to solve systems of equations. And we can really do those in different orders, whichever order we need. We're trying to get a 0 and a 1, and then we're trying to get a 1 and a 0. So we just do whatever steps we need to get there. So that's what this was doing. Working through the steps to get at the end 1, 0, 0, 1. If we had 3 equations and 3 variables, we'd have a 1, 0, 0, 0, 1, 0, 0, 0, 1. Let's check that. Good job. All right, and that's the end of that. Okay, let's go to our assignment for this. All right, let's do our assignment. Again, when I click on the assignment, it takes me to a Khan Academy page. Oh, let me go back and look at this. Now, remember, when you do the assignment, you have to scroll down on the screen, and this is where I'm going to copy and paste how I did. So you click on this, but if you scroll down, you find this is where I turn it in. But it opened this other window over here. I'm going to close that little half tab. I don't want that in my way. Okay, ready to practice. My name's up the top, so it's going to keep track of how I do. And I hit the let's go down here in the corner. Let me make this a little bigger for us. Okay, I need to perform this operation. Row 2, row 3, trade places, double arrow. So -10, we know the first row doesn't change. Now be careful, I missed one yesterday because I forgot to hit a negative. I just typed like an 8 instead of a -8, and I got it wrong. I was like, oh no. So I had to redo the whole thing over again. So the third row and the second row trade places. So 1 for -6, 2. And this is now the second row's numbers becoming the new third row. So nothing changed except for this used to be the third row. This used to be the second row. Great work. All right, next question. All right, let's see. Row 3 plus 2R1 equals R3. All right, I'm going to put the first and second row. Tell me what the third row should be. I'm going to go ahead and enter the first and second row because it didn't say to change those. But what is the new third row? All right, I see some numbers popping in. Looks like everyone's getting the same thing. So it's to take row 3 and add double the first row to it. So row 3 started with a 0, and I'm supposed to double the first row. So that would be 2 plus the 0 is 2. Now I double the first row here, it would be 12, add the third row to it. So that's 14. 18 plus 2 is 26. Plus 4 is 10. Okay, great job, everyone. Let's see if we're right. Next, good job. Now we're supposed to take -5, row 1 becomes row 1. So looks like row 2 does not change. Oh, there's a -8. Got to get that right. Oh, there we go. -8, 4, 5, 2, -4, 2, -6. All right. So -5 times row 1. So we're just multiplying all the numbers by -5. So that's a positive 45. That's a positive 10. That's a -15. And that's a -35. Positive, positive, negative, negative. All right, one more, and we can turn this one in. Perform the row operation. Oh, that gives us an easy one. We're just swapping rows. Here, I'll do this one. 5 negative. Oh, I didn't do that. 5, -2, 1, 1. That didn't change. 1, 1, 7, -3, 3, 0, 0, -2. All right, there we go. Let's check. Okay, so now store. This is where I take a screenshot. So I do a screenshot with this little snip tool because that's just easy for me. Oh, come on. Here's my screenshot. I go back here, scroll down to the bottom, and I can paste it. Oh, all right, thank you. Paste it, paste. Boom, there it is. 4 out of 4 correct. Submit my work. Full points. Okay, now if I go back to week 24, I'm finished with this first folder. Finished with the first folder. All that's left is this second lesson and a quiz. All right, I'm going to pause right here. I'm going to pause. Before we get to this last lesson, I'm going to take attendance. And here's how I'm taking attendance today. I'm going to take a poll. So go to the polls. That's that little triangle, square, circle that's right next to the chat. And this is how you get counted present today. I just launched the poll. A little triangle, square, circle icon right next to the chat. Go there and count yourself present. I'll give you some time for that. This is where I said I have counted many, many people absent this week because they weren't answering my poll. It's like, if you're here, if you're in class, this is not a big problem. If you logged in and left and never came back, you're not in class. Your Chromebook's here in class. Yay, your Chromebook gets counted present, but you get counted absent. There are 21 people I can see on the screen right now. 13 of you are present. But there's 21 people right here on the screen that are on the meet. A lot of them I can't see. Their cameras are on, but I can see the ceiling. I see no people. And that's probably some of the ones that are going to be counted absent because they're not telling me, yo, I'm here, Mr. Brock. But I found this is a great way to take attendance to see who's actually here. Because I know you were here at the beginning and your Chromebook stayed in class. That's great. But you're not learning anything if you're over there playing video games and your Chromebook is in class. Or you're out watching Netflix in the other room and your Chromebook's in class. You need to be in class. So I'll count all 14 of you present today. Thank you for being here. Won't have any trouble with these matrices because it gets a little trickier with this row operations, right? So let's look at this last lesson, which is about solving systems of equation, which we just did one on paper. So this is just another look at that, a lesson that just specifically goes over that. I'm going to leave that poll open for just a few minutes, but I will close it. All right, solving linear systems. It's right down here in week 24. See, this doesn't have an assignment. This is just a lesson, but this we covered on the quiz. All right, close that other window. Oh, this is a video. Okay, this is a video, so I need to make sure you can hear this. And he's going to do the same type of thing that we just did on paper. So this is a great one for you to go back and look at later. If you are looking at the quiz and you're like, uh-oh, I'm struggling with the quiz, save the quiz. Don't turn it in. Save it. Go back and review this. All right, let's take a look.
Figure it never hurts getting as much practice as possible solving systems of linear equations. So let's solve this one. And what I'm going to do is I'm going to solve it using an augmented matrix, and I'm going to put it in reduced row echelon form. So what's the augmented matrix for this system of equations? 3 unknowns with 3 equations. So it'll be, I'll just have to do the coefficients. So the coefficients of the x terms are just 1, 1, 1. Coefficients of the y terms are 1, 2, and 3. Coefficients of the z terms are 1, 3, and 4. 1, 3, and 4. And let me show that it's augmented. And then they equal 3, 0, 3, 0, and minus 2. Now I want to get this augmented matrix into reduced row echelon form. So the first thing, I have a 1 leading 1 here. That's a pivot entry. Let me make everything else in that column equal to a 0. So I'm not going to change my first row. So it'll just be a 1, a 1, a 1, and then my dividing line, and then I have a 3. Now, to zero this out, let me just replace the second row with the first row minus the second row. So 1 minus 1 is 0. 1 minus 2 is 1 minus 2. Actually, a better thing to do, because I eventually want this to be 1 anyway. Let me replace this row with the second row minus the first row, instead of the first row minus the second row. I can do it either way. So the second row minus the first row. So 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. And then 0 minus 3 is minus 3. Now, I want to also zero this out. So let me replace this guy with this equation minus that equation. So 1 minus 1 is 0. 3 minus 1 is 2. 4 minus 1 is 3. Minus 2 minus 3 is minus 5. Fair enough. So I got my pivot entry here. I have another pivot entry here. It's to the right of this one, which is what I want for reduced row echelon form. Now I need to target this entry and that entry. I need to zero them out. So let's do it. So I'm going to keep my second row the same. My second row is 0, 1, 2, and then I have a minus 3 in the augmented part of it. And to zero this guy out, what I can do is I can replace the first row with the first row minus the second row. So I get 1 minus 0 is 1. 1 minus 1. There's a bird outside. Let me close my window. So where was I? I'm replacing the first row with the first row minus the second row. So 1 minus 0 is 1. 1 minus 1 is 0. No, I don't want to make it. 1 minus 1 is 0. 1 minus 2 is minus 1. And then 3 minus minus 3. So that's equal to 3 plus 3. So that's equal to 6. Right? 1 minus 0 is 1. 1 minus 1 is 0, negative 1. And then 3 minus negative 3, that's 6. I always want to make sure I don't make a careless mistake. Now let me get rid of this entry right here. Let me zero that out. So let me replace the third row with the third row minus 2 times the second row. So we have 0 minus, well, 2 times 0. That's just going to be 0. 2 minus 2 times 1. That's 2 minus 2. That's 0. 3 minus 2 times 2. That's 3 minus 4, or minus 1. And then finally, minus 5 minus 2 times minus 3. Let me write that down. Minus 5 minus 2 times minus 3. That's minus 5 minus minus 6. That's minus 5 plus 6 is equal to 1. I really wanted to make sure I didn't make a careless mistake there. So that is equal to 1. So I'm almost done, but I'm still not in reduced row echelon form. This has to be a positive 1 in order to get there. It can't be anything other than a 1. That's just a style of reduced row echelon form. And then these guys up here have to be zeroed out. Well, the easy thing to do, let me just multiply this equation by minus 1. So then this becomes a plus 1, and then that becomes a minus 1. And then I just need to zero out these two guys up here. So let's do it. So my equation, I'm going to keep my third row the same. My third row is now 0, 0, 1, minus 1. 0, 0, 1, minus 1. And now I want to zero this guy out. So what I can do is I could set my first row equal to my first row plus my last row. Because if these two add up, they're going to be equal to 0. So what do I get? 1 plus 0 is 1. 0 plus 0 is 0. Minus 1 plus 1 is 0. 6 plus minus 1 is 5. Now I want to zero this row out. And to zero this row out, what I can do is I'll replace it with the second row minus 2 times the first row. Right? So 0 minus 2 times 0 is just 0. 1 minus 2 times 0 is just 1. 2 minus 2 times 1 is 0. Minus 3 minus 2 times negative 1. Let me write that down. Minus 3 minus 2 times minus 1. Don't want to make a careless mistake. So what is that equal to? This is equal to minus 3 minus minus 2, or minus 3 plus 2, which is equal to minus 1. So that's equal to -1. And now I have my augmented matrix in reduced row echelon form. Reduced row echelon form. My pivot entries are the only entries in their columns. Each pivot entry in each successive row is to the right of the pivot entry before it. And actually I have no free variables. Every column has a pivot entry. So let's go back from the augmented matrix world and kind of put back our variables there. So what do we get? We get x plus 0y plus 0z is equal to 5. That's that row right there. We get 0x plus 1y plus 1y plus 0z is equal to -1. That's that row right there. And then finally, we have 0x plus 0y plus 1z is equal to -1. That's that row right there. And just like that, we've actually solved our system of 3 equations with 3 unknowns. That's the solution right there. I just wrote it in this way just so you see it corresponding, but obviously I could have written them closer to their equal sign. So hopefully you found that vaguely useful.
All right, so that's how that works. And when he's talking about, let me show you this real quick. When he says reduced row echelon, that's a fancy way of just getting it down to ones and zeros. So let me show. We had done that on paper here. I'll bring it up real quick. This is reduced row echelon when you only have ones and zeros on the variable side. You know, this side is what's on the equal side. So these could be any numbers. But all the variable columns, this is the x and that's the y. When the x column and the y column, and if there was a z column, there's only one and the rest are all zeros. So he had 1 0 0 with some number over here, 5, I think it was. And then he had a 0 1 0 and a -1, and he had a 0 0 1 and a -1. So the x column only had 1 1, the y column only had a 1, and the z column only had a 1, and it was also the only one in the row. Just an x, just a y, just a z. So that's how the reduced row echelon, when he uses that terminology, that's what it's talking about. This is not reduced row echelon because there's 2 1s in that same row, and there's 2 1s in the same column. You got to get down to where it's just 1 1 and the rest are all zeros in every column and in every row, except for the right side where it equals. So don't let him confuse you when he says reduced row echelon. It's just saying that's really gets it down to the solution. The final numbers there. All right, let's take a look at the quiz, because the only thing in that folder was that one lesson, so I'll close that folder. So we've done both of the folders. All that's left is the quiz. So we'll look at it together. Oh, you get 3 attempts. I was very generous today with the quiz. So if you don't do well, you get 2 more retakes. All right. I want to look at this together because I don't want you to get confused. Because when you look in Buzz, you see, whoa, what is this? BEG, I think ATRX2, ampersand, 4 ampersand minus. Ignore this line right here. That's how Buzz has to do it in order to show it as a matrix. This is correct. So look at the question. What are the dimensions of the following matrix? And then ignore all of that mess right there because it doesn't mean anything. It means something to Buzz. It's telling Buzz how to display this. But I wish it wouldn't show that, but it does. But that's okay. You can just ignore that. What are the dimensions? So this goes back to the very first lesson we had. What is the dimensions? Is this a 6 by 6, a 5 by 6, a 5 by 5, 6 by 5? What is that? Which is the 3, 4 element in this matrix? All right. And remember, if you forget this stuff and you're answering this, like, okay, I know what this is. I know what this is. And then I forget, you can save and exit down here. Save and exit. It'll save your work. And maybe you want to go back to last week and say, how did that element thing work? Element things. So I can go back to that lesson or that video and look at that and say, oh, that's right. Then I'll come back to the quiz and pick up right where I left off. because it'll say continue now because I'd already started it. So what is the 3 form element? How would you write this as a matrix? That's from last week as well. Which one of these 4 is correct for this system of equations? How would you write that? Perform this row operation. Row 1 plus 4 row 3 becomes row 2. On this matrix, which one of these 4 will it be? So some of these you should be able to eliminate real quickly. Like this has 4 rows and 3 columns. This has 5 rows and 3 columns. Would it change that? Oh, and this one. Oh, okay, I'm gonna do an example of this as well because I don't want you to miss this. I have students miss this every year, and it's really very, very easy. And we didn't really specifically look at a lesson like this, so I do want to show you a sample problem so you don't miss number 5. Please don't miss number 5. I'm going to do it at a very, very simple matrix, but it works the same way. I'm going to do a 2 by 3 matrix. I'm sorry, I'm going to do a 3 by 2 matrix. Okay, and I'm going to put an X right here, and I'm going to put a Y right here, and I'm going to put 1, 2, 3, 4, 5. I'm going to put -2, -3, -5, -6, -7. Oh, maybe I don't want to do that. Make this -8. Make this a +6. And make this, I'll make this an 8 as well. Okay. See, these matrices are being added. Let's talk about how to add matrices. It's important to pay attention. Sometimes they're subtracted or sometimes they're added. So this really isn't in your notes, so I want to make sure you have it. If I'm going to add 1 to -2, I take the first row, first column, add it to the first row, first column, and that is the first row, first column. 1 plus -2 is -1. I'm going to do this one as 4. I'll get to that in a minute. And I'm going to do this as 5. 3, which one am I adding 3 to? It's added to the -8, right? Because this is the second row, second column. 3 plus -8 is -5. The bottom left, third row, first column, is added to the bottom left, third row, first column. And 5 plus -7 is -2. So, looking at this matrix, and I will highlight them for you. What are X and Y? Put that in the chat. What is X and what is Y? I'll try to make this even bigger for you. I'll bring it down here closer. This is number 5 on the quiz. So I'm wanting to make sure you understand how it works because it's really very simple as long as you pay attention and understand how it works. Rebecca, Bridget, Heidi, Kendall, y'all going to do well on the quiz. Good job, Allison. Yes, if you're adding those together, if we're adding, this is add, so X plus -8 equals 4. So X has to equal 12 because 12 plus -8 would be 4. When we look over here, 2 plus Y equals 5. y equals 3. It is that simple. Don't make that complicated. I have students miss that every year. And I'm like, oh, please don't miss this. Please don't miss that. It is on the quiz. It's just a bigger matrix, but it still works the same way. It's either being added or subtracted. Remember, it may be subtract. Don't miss it if yours is subtracting, because sometimes your problems can be different than the one I show on the screen, because it's going to randomly pick different problems for you. So make sure you know whether it's adding or subtracting. I don't want you to miss it because it did something different for you. So, okay, that's it. We've gone over all the lessons this week. There's 2 things to do. There's the one assignment on Khan Academy, and then there's the quiz in Buzz. Then we'll be halfway through matrices after this week. Hopefully you can get this done quickly. I'm hoping this is an easier unit where you can be done early in the week and have a lot of free time to get your other classes done and have a great weekend. So this is a B-Day Friday. So if your grade's below 70%, we'll be here Thursday and Friday. Or if you just want to come say howdy or come get some help with anything, I'll be here both those days. But otherwise, we'll see y'all next week. So have a great day and enjoy your week. Get this stuff done early.